try this. The air's really active today, isn't it? Beautiful, though. Feel the cold, wet rain on your face. Nice, brisk breeze. See those clouds? Know where they are? Same place we are. They're in the atmosphere. The atmosphere. Isn't it great? Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the ozone layer. We block out ultraviolet light so you don't have to.
We live in an ocean of air. Our atmosphere is thick enough to let us live and breathe, but it's too thin to float or swim in. If you think of the atmosphere as an ocean of air, we live on the bottom.
Sorry, Bill.
Our atmosphere is thin, very thin. In fact, if this globe were the Earth, the atmosphere would only be this thick. I mean, this thin. Only 10 kilometers. Yet that's thick enough to let every living thing on Earth, including you and me, breathe. Now take a look at these. These are our atmospheric tubes of science. And right now, they're full of an invisible mixture of gases.
What would that be?
It's air.
Oh, yeah.
Now down here, we have 2 thermometers. So let's say that down here is like the surface of the Earth where the lab is, and up here is the icy blackness of space. And see, we have big chunks of ice here. Now, what would happen if the Earth had no atmosphere, if there were no air above us?
I don't know.
Well, let's try it. Using this pump, we'll take all the air, all the atmosphere out of this tube. There. We've pumped almost all of the air, almost all of the atmosphere out of this tube. Now take a look at this thermometer. Do you see that it's reading a few degrees cooler than this one? That's because there's no air, no atmosphere. That's because air, the atmosphere, acts like a blanket and keeps the world warm. In fact, most jackets and blankets work by having fibers that hold air next to your body, and that's what keeps you warm. The atmosphere has layers, like blankets, so it keeps the world warm, and it protects the world from comets and meteors. And the atmosphere is where all clouds and rain hang out. The atmosphere is wild.
At the time the moon was losing heat, it was also losing its volcanic gases. And it is from such gases that atmospheres form. But with a weak gravitational field, the moon was unable to retain even the heaviest gases. Earth's gravity held most of its gases that eventually formed a primitive atmosphere.
Universal Pictures presents a tale so amazing, it's rising to the top of the box office. Catch it before it disappears into thin air. It's the incredible Voyage to the Top of the Atmosphere. Tremble as the turbulent troposphere whips up weather and churns massive amounts of innocent air. Stagger as the strapping stratosphere protects you from deadly ultraviolet light. Thrill as the titanic thermosphere thrashes gamma rays and absorbs heat from the sun at the same time. This summer, see the stars shine like you've never seen them before as you voyage to the top of the atmosphere.
We'll be operating this sailplane in the troposphere. It's the lowest layer of the atmosphere and the thickest layer. It's thick enough to support me and this whole plane. It's pretty wild. We're getting higher and higher in the atmosphere. The lower atmospheric pressure is affecting our altitude indicator. And we can tell pretty much how high we are, not only by looking, but by looking at that indicator. The less atmosphere over our heads, the lower the atmospheric pressure. And that's how we can tell our altitude. The lower the pressure, the higher you are. That's how pilots figure out how high off the ground they are. They set their altimeter to the pressure at the ground. And as they go up, the pressure goes lower. The lower the pressure, the higher the altitude. You with me? There's a lot of air in the atmosphere. About 5.5 billion tons of it. On somebody my size, there's about a ton of air pushing down on me all the time. But the pressure in the atmosphere changes depending on where you are. It's hot. We're in Death Valley. Death Valley is the lowest point in North America. There's all this atmosphere over our heads. Take a look at this. It's my pop bottle barometer of science. What I've done is stretched a balloon over a small pop bottle. And I put it in a larger pop bottle with ice and water. That keeps it at about the same temperature. Then the air pressure pushes down on the balloon and makes this straw needle go up. And look, we're here in Death Valley, and there's so much atmosphere over our heads. There's so much air pressure that the needle is off the scale.
Something's off the scale.
It's off the scale.
Yeah.
You know what I'm saying?
Yeah, I know.
Off the scale.
Mm-hmm. That's
a lot of pressure. Ugh. It's air pressure pushing down on us. Ugh. Look, it's off the scale. Off the flippin' scale the other way. That's because we've climbed up to 2,000 meters. That's, well, so it's over 6,000 feet anyway. That means there's less air over our heads, less atmosphere. And that means less pressure pushing down on the balloon. So it swells up and makes the needle point down the other way, off the scale, all because of pressure.
Instruments tell us of jet streams of air, fierce winds circling the globe far above the clouds we see. We live at the bottom of a turbulent ocean of air.
Let's go swimming.
You know how your ears hurt when you dive into the bottom of a pool? It's from the weight of water pushing in on your ears.
The same thing is true in the atmosphere. The weight of the air pushing down makes about 3 kilograms on every square centimeter.
You've got frog lips, Bill. Why is that?
If you ever get a chance to go up in an airplane, the pressure is much lower, so you may feel your ears pop. Because up here, the pressure is lower on this side of your ear than it is on the inside. And sometimes it equalizes, and that's when it pops. Oh. Troposphere!
Stratosphere!
Why, hello there, and welcome to my Rocky Mountain High Country Kitchen. You see, there's less air above our heads in the mountains, so the water I'm heating in this pot can boil more easily. With less atmosphere, less air pressure pushing down on the water only needs a little bit of heat before off it flies in a bubbly, steamy bowl.
Take a look at this. It's our plastic cylinder of science. And in here is this thick plastic disc. Now, right now, there's air pushing down on the disc, and the air inside here is pushing up. And the forces are about equal, so the disc just stays here. But what would happen if we took all the air out from underneath of the disc? We can do that with this pump. Now then, we get just the weight of the atmosphere from here all the way to outer space, pushing down on the disc with nothing underneath it pushing up. We can measure the force of this with this scale. This takes a minute, so hang on.
Bill? Bill, I'm getting a little bored here, Bill. Want to play a quick game of cards, guys?
The atmosphere's pushing down.
Just deal them out here.
about 150 kilograms of weight. That means the atmosphere is pushing down on this disk with 150 kilograms. Pushing down all day, all the time. And just think, on a guy my size, where I'm bigger, the atmosphere pushes down with almost a ton. All day, all the time. Isn't that wild? See, the atmosphere is thin, but it's heavy.
Welcome back.
Up there, down here, over there, atmosphere is everywhere.
Woo! Science!
The Fantastic Five, superheroes of the atmosphere, protecting planet Earth from danger. Meet Exosphere, the top of the heap, living on the edge of outer space. Her atoms may be few, but they soar along faster than a speeding bullet. Then there's Thermosphere. He may be thin, but he blocks out deadly gamma radiation, keeping us all safe. Meet Mesosphere, in the middle of it all, and the coolest of the bunch. She melts meteors and mixes things up with her powerful winds. Stratosphere takes heat energy from the sun and converts oxygen into ozone, blocking ultraviolet light in the process. Wow! Troposphere is the stormy one. She is our closest superhero who brings us rain, wind, snow, and all weather. The Fantastic Five. They take the fear out of atmosphere.
7, 6, 5, 4, 3, 2, 1. Release. We're free of the tow plane now. Hey, we're soaring high in the atmosphere. But as high as we are, we're still in the troposphere. The troposphere is where we live. It's a great place. It's a blast. Oh, yeah. Oh, yeah. And down and up. What a blast! It's science! Ah, yeah, science! If mountaintops are closer to the sun, why is it always colder up there than it is down here in the city? Well, please consider the following. Our atmosphere is thin, but it's thick enough to keep us warm. Now, when you're wearing a coat like this one, it keeps you warm because it holds air next to your body. The same thing with the atmosphere. There's more air above us when we're down here in the city than when we're way up here in the mountains. So it's like the world's low places are wearing more coats. They're wearing more air than these places up high in the mountains. Now, as you travel up through the atmosphere, it gets colder and colder because the air gets thinner and thinner until you're up around 10 kilometers. That's when you leave the troposphere and enter the stratosphere. Anyway, the rate at which it gets colder is called the lapse rate. And it's about 5.5 degrees Celsius per kilometer. So a mountain, say 3,000 meters high, let's see, that's about 10,000 feet, would be about 17 degrees Celsius colder than it would be down here in the city. And that's plenty cold enough for there to be a spring shower in the city while it's snowing up in the mountains. Thank you for joining me on Consider the Following.
Hi, friends. You say you're living on Venus and you're having a little trouble breathing that atmosphere? You need to come down and see me at Therm's Sphere of Atmospheres. Is this the kind of planet you're putting up with, friends? Breathing those noxious sulfuric acids? You can't breathe that. You don't need that. Get rid of that whole planet. Come down and see me at Therm's. Take a look at this little beauty, friends. Only 3.5 billion years old. It's like new, and it's got a beautiful combination of oxygen and nitrogen that makes it just a pleasure to breathe. Now that is atmosphere, friends, and you're not gonna...
The atmosphere keeps the Earth warm in kind of the same way this jacket keeps me warm. Now, when an atmosphere keeps a planet warm, we call it the greenhouse effect. It's the same thing that keeps this greenhouse warm. It works like this. A greenhouse is covered with layers of glass. Light from the sun, the light that we can see, what we call visible light, goes right through it. It hits the plants growing inside and is given off as heat. Now, the heat doesn't go right through the glass. No, it's reflected back inside. It's bounced back in. And that's what keeps a greenhouse warm. The same thing happens on the Earth. But instead of a layer of glass,
there's a layer of air, the atmosphere. So light from the sun goes right through the atmosphere, it hits the Earth's surface, and is given off as heat. The atmosphere holds the heat in. Now, without the Earth's atmosphere, the Earth would be very, very cold at night and very hot during the day. The atmosphere keeps everything kind of even and nice here. It's the greenhouse effect. You can see it. Oh.
We have learned a great deal about the atmosphere we live in. The camera, speeding up the movement in the sky above, reveals restless forces.
Car exhaust is a big source of air pollution. A lot of the chemicals that go through a car engine don't get burned completely. They end up in the atmosphere, and then sunlight makes them corrosive. Since there's light and chemicals, we call it photochemical smog. It's bad. And I think your car needs a tune-up. There's another type of air pollution that we need to talk about. It doesn't come from car exhaust. Now, it comes from electric plants where we burn coal to make electricity. Sometimes the coal has sulfur in it. The sulfur gets up in the sky, and when it rains acid rain. Sulfuric acid from the sky. Now, I'm going to mix a little sulfuric acid with sugar. Watch. Now, you have sugar in your body, too. And so do plants and other animals. Now, suppose you were trying to live in a lake, river, or stream where there was acid rain falling. Wouldn't be a good thing. That's why we call it pollution. Pollution.
My name's Hillary Thrift, and I'm 16 years old.
I'm Dustin, I'm 16 years old. I'm Josh, and I'm 17 years old.
I'm Carrie, and I'm 17.
Okay. I'm scared. Let's go.
We're making a skydive.
I like falling through the air with other people, looking over, seeing their facial expressions when your face gets blown back away from you from the wind. It's a lot like when you have your head out the car window when the air is blowing against you and you can't really breathe like that.
As you're getting higher, everything else below you is starting to look like little toys and little log houses and everything, and it's really great.
We're going to free fall in about a minute doing 120 miles an hour. Green light! Green light!
Through the atmosphere.
Yeah.
13,500 feet.
Above the ground.
The troposphere is only 10 kilometers thick. If you ran around a regular track 25 times and you were going straight up, you'd be at the top of the troposphere. Right, Coach?
That's right, Bill. You better get moving if you want to run the distance of the troposphere.
The troposphere is the part of the atmosphere where we have weather. It's where we have clouds and rain. Right, Coach?
Move it there! You're halfway there! Move it, run, run, run!
The last 100 meters. Just enough time to tell you. As you get higher in the atmosphere, the air gets thinner and there's less oxygen to breathe. Right, Coach?
Good job, Bill. Now, we want you here bright and early in the morning. Tomorrow, I'm going to have you run the mesosphere.
Remember, friends, I can't help you breathe any easier unless you come on down and see me today at Therm's Sphere of Atmospheres, open till the end of time.
Max and relax, you have nothing to fear. Earth is protected by its own atmosphere. Breathe in, breathe out, can you dig it yet? Air around the earth keeps it warm and wet.
Let me lay this down, cause it ain't no job. Without the atmosphere, you wouldn't be alive.
Just a layer of air that surrounds the earth.
What's so important to life, you can't count its worth.
5.5 million billion tons weighing down on earth doesn't sound like fun.
But that's how much the atmosphere weighs.
It's an ocean of air, you'd be highly amazed. Max and relax, you have nothing to fear. Earth is protected by its own atmosphere. Breathe in, breathe out, can you dig it yet? Air around the earth keeps it warm and wet. Now you know the air's not as light as a feather.
Chill out for a minute while we talk about the weather. It jams in the troposphere, that's the norm.
The atmosphere's bottom layer where the clouds can form. Water evaporates from oceans, lakes, and pools.
Warm air rises in the sky and then cools. Then the water comes down as rain, sleet, or snow. It's happening now, so me and home's gonna blow.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some stratus clouds to monitor. See ya.
Produced in association with the National Science Foundation.
A place like the moon doesn't have enough gravity to hold an atmosphere on its surface. So whenever we go there, we have to bring our own. That's why we wear these bulky suits. And my atmosphere in here is kind of warm. Is yours? Huh? Over there? Is it?
Now, when you're in outer space, like these guys were in Apollo 17, you've got to take your own atmosphere with you. Now, here on Earth, you know, we have about 100 kilopascals of pressure. Out in outer space, they only use about 1/5 of that. But anyway, when you're flying around in outer space, you've got to keep the door closed. Did you guys grow up in a barn?
What a blast! It's science!